So good day. We are Ego 7 and we are here to present our case study entitled A Case Study about Overheating Electric Motors, One Root Cause of Insulation Failure. So I am Carmelo Gonzalez and this is the main identification of main problem. In the world of electrical engineering, electric motors serve as a backbone of numerous industrial processes and applications. These powerful devices tirelessly drives machinery providing necessary force to keep the modern world in motion. However, despite their efficiency and reliability, electric motors are not immune to problems. One of the most common and detrimental issues encountered is overheating, which can lead to insulation failure. This case study delves into intricate detail of overheating, electric motors, and associated insulation failure. This case study begins with exploration of key factors contributing to motor overheating. Various aspects such as excessive loading, improper ventilation, ambient temperature, and electrical anomalies are examined in details. Furthermore, this case study examined the consequences of insulation failure in electrical motor. Beyond the immediate operational disruption, insulation failure can result in catastrophic motor failure, unexpected downtime, costly repairs, and potential safety hazard. To provide comprehensive understanding, this case study delves into diagnostic method and tools utilized in identifying overheating issues, temperature monitoring, infrared thermography, and other advanced techniques are explored, highlighting their effectiveness in early detection and troubleshooting. This case study on overheating electrical motors and insulation failure serve as a valuable resource for professionals in field of electrical engineering, maintenance, and motor-driven industries.
For
For
the
the
analysis of the
analysis of
problem,
the problem,
we have four: excessive loading, improper ventilation, ambient temperature, and electrical anomalies. For the excessive loading, the primary reason of excessive loading leads to motor heating lies in the increased current flowing through the motor's winding. As the load surpasses the motor's rated capacity, it demands a higher electrical current to meet the additional power requirements. The increased current leads to an elevated level of resistance in the winding, generating excess heat. This heat in turn accelerates the aging and the degradation of the insulation materials surrounding the windings, eventually leading to insulation failure. In relation to this, STAP 2019 stated that the coal-fired power plant in the United States, a 7,000 HP 6.6 kilobit motor, was running with only 7% overtime. Next is improper ventilation. For your improper ventilation is a significant contributing factor to the heating of electric motors, posing serious risks to their performance and longevity. Effective ventilation plays a crucial role in dissipating the heat generated during motor operation. When ventilation is insufficient or compromised, the heat produced by the motor gets trapped, leading to increased temperatures and potential damage to critical motor components. Proper ventilation facilitates the circulation of air around the motor, carrying away excess heat and maintaining a favorable operating temperature. Next. For the ambient temperature, the ambient temperature surrounding an electrical motor plays a crucial role in its heating and overall performance. As the temperature in the environment rises, the motor is exposed to higher thermal loads, which can significantly impact its efficiency and reliability. Understanding how ambient temperature affects the motor heating is essential for maintaining optimal operating conditions and preventing potential failures. Last is electrical anomalies. Electrical anomalies play a significant role in contributing to the heating of an electric motor, posing a serious threat to their performance and longevity. An electrical anomaly refers to any irregularity or deviation from the normal electrical operating conditions within a motor. These anomalies can arise from various factors such as voltage fluctuation, unbalanced loads, harmonics, and short circuits. The presence of these anomalies disrupts the harmonious functioning of the motor, leading to increased resistance, excessive generation, and insulation deterioration.
So this is the this is the effective solutions. First is to avoid excessive loading. Second is to implement a proper ventilation. Third is to maintain a good ambient temperature and lastly inspect for electrical anomalies. First, excessive loading contributes to motor heating. Proper load analysis and motor sensing are important. Therefore, continuous monitoring detects and addresses overheating. Mitigating excessive loading prevents insulation degradation and extends motor lifespan. Understanding and implementing measures ensures optimal motor performance. For improper ventilation, proper motor ventilation prevents overheating and insulation degradation. Adequate clearances, fan sizing, and vent placement enhance airflow. Regular maintenance and cleaning prevent airflow obstruction by contaminants. Improper ventilation reduces motor efficiency that can cause insulation degradation. Addressing ventilation issues ensures optimal motor performance and longevity. Third is to maintain an ambient temperature. So proper ventilation and cooling are essential to address the impact of ambient temperature on motor heating. Adequate airflow, ventilation systems, and sustainable insulation help maintain the motor within its optimal temperature range. Selecting motors with appropriate thermal ratings or for anticipated ambient conditions prevent overheating. Higher ambient temperatures include cooling mechanism accelerate molecular degradation and affect electrical characteristics. Lastly, the electrical anomalies. Stable power supply and protective devices mitigate electrical anomalies and motor heating. Regular inspections, maintenance, and loading reduces the risk of anomalies and other heating effects. Electrical anomalies disrupt motor functioning, causing resistance heat generation and insulation deterioration. Lastly, addressing anomalies through stable power supply and maintenance ensures optimal motor performance. Ayun.
Good day, I'm William James Ardones and I'm here to elaborate the links of our case study entitled Overheating that can cause insulation degradation of a electrical motor. Now, for the links to course reading. First, in our course reading, the rotor could overheat at a much higher rate than the stator. The rotor blades would expand at a higher rate than the stator blades. This could lead to wrapping between the blades, resulting in significant damage to the turbine. So this statement is quoted in one of our course reading, and this phenomenon is caused by thermal expansion of a material due to excessive heat. So given the fact that um, overheating is a phenomenon wherein the stator or the motor or the electrical motor suffers from an excessive heat or excessive rise of temperature inside the electrical motor, mainly in the rotor and the stator. There could be a chance wherein the stator and the rotor would rub against each other, causing an incident. another course reading or another quote in our course reading. In AC machine design, of the most critical parts is the insulation of the windings. When the insulation breaks down, the machine sorts the machine shorts out. The repair of machines with shorted insulation is expensive and sometimes impossible. The temperature of the winding should be limited to prevent the insulation from breaking down due to overheating. So another quote that supports the cause of our case study we're in. This quote from our course reading emphasizes the importance of proper maintenance and proper preventive measures prevent or to prevent or stop the overheating to occur in an electrical motor, cause the repair is expensive or sometimes is impossible. So when an electrical motor suffers from overheating and suffers a major damage, um, some worse to come, you need to buy another equipment, another machine, or another electrical motor. The last course reading or the last code for our course reading, the increase in temperature usually degrades the insulation, causing it to fail by another cause, such as shock, vibration, or electrical stress. A rule of thumb indicates the life of an AC machine is half for a temperature rise of 10% above the rated temperature of the windings. So this code implies that a sudden increase in the rated temperature of the electrical motor could mean a lot to the machine. A 10% increase is equivalent to half life or cutting half the life of the electrical motor. Now, for the additional research that we gathered or the researchers gathered during this case study implementation, the first study is the ventilation fan fires overheated windings lead to failed thermal limit switch. So this study is all about an occurrence of overheating of an electrical motor that it affects the overall system of the overall system of a um, control system and leads to an incident and created a fire. Second study, determination of the insulation condition in synchronous generators, industrial methods, and a case study. So in this study, the rotor insulation system in electrical motors is subjected to different stresses compared to the stator winding insulation, mainly temperature and centrifugal forces. Rotor insulation fault occurs less frequently than the stator winding faults due to low field winding currents, but the thinner rotor insulation makes it susceptible to heating and temperature spikes and lead to copper heat. So, based from this statement, from this case study, we can define or we can conclude that the windings in the rotor is so thin that a sudden increase in heat can lead to copper heating and can melt the or can deteriorate the insulation winding inside or in the armature slots of the rotor. The last study is the reliability assessment and improvement of large power induction motor winding insulation protection system using predictive analysis. So in this study, insulation material in electrical motors undergoes normal thermal aging over time. However, premature failures are often caused by overheating, resulting from factors such as overcurrent, overload, unbalanced voltage variations, and high ambient temperature and obstructed ventilations. These thermal stresses can lead to the lamination or cracking of the insulation material. So, based from this study, there are several factors that can affect the integrity of the insulation material of the um, insulation in the rotor or the armature slots, such as the overcurrent, overload, voltage imbalance or unbalanced loads, voltage variations, high ambient temperature, and obstructed ventilations. And all of these stimuli that can cause the overheating of an electrical motor is already explained and expounded in our case study. So that's all for the additional researches and links to the course readings of our case study.